everybody? Yes. Okay. Okay. Thanks for that. So, hi everybody. Welcome to Global Azure Bangalore 2023. I'm Anurag. I work as a senior AI architect with Schneider Electric AI Hub, and yes, I work uh, mainly on Databricks, Snowflake. My expertise is into creating, uh, taking the organizations through their digital transformation, wherein have been involved into creating data lakes and helping data science teams, uh, architecting machine learning solutions for data science and AI ML use cases. So with this, I would just start uh, with what basically is. So everybody, first of all, this is a Microsoft research topic. Okay, not lot of people have started using in the industry, but yes, slowly this will garner lot of attention, and people have to at one point start using these tools. So I just wanted to give this is not a very easy topic. It has taken some time for me as well to digest. But yes, the agenda for the topic is that on a very high level, I would like to introduce these responsible AI tools from Microsoft to you guys. And this session would be very, very beneficial for data scientists, machine learning engineers, and people who are into the AI ML field. This topic would be of great help to them, because slowly the trend and the industry is evolving to maturity, wherein we might need to incorporate responsible AI into our use cases. So before we begin, we all understand what is an AI use case. So basically an AI or an ML use case is something where you, on the left hand side of the spectrum, you get a lot of data, you transform the data, keep it, and then you start analyzing the data using a plethora of tools that are available in the market, right? And then you have data scientists who write algorithms to get insights from your data. And at the end, what happens is the data scientists give these algorithms to you, and the software engineers or the ML engineers package these solutions and provide it for consumption to the outside world. So basically, this is an end-to-end machine learning cycle on a very basic front. There are intricacies in each and every step, but on a broader level, data ingestion, data storage, machine learning algorithm, and exposing to the outside world. So we all have been hearing that lot of machine learning or AI use cases are not making into production. So that's a different topic altogether, wherein there are concepts of ML ops and all. But when an AI use case comes into production, we have to make sure that it follows principles of responsible AI. So why responsible AI? Now you have there was a recent project from Google named Project Galactica. So they they put it into production or use cases, and then what happens within just 2 days there was a legal notice to for that AI tool, and they had to bring it down. So now you have seen that lot of AI, and especially the NLP use cases, the natural language processing, wherein you have chat GPT and lot of things that are kept coming, and they are being open to the world. Now, the point is, with these tools being exposed to the outside world, we have to make sure that in no way these AI tools should be hampering or disrupting the normal processes. Because if at all there is a disruption due to the use of the AI tool, there will be a whole lot of havoc everywhere. This could lead to legal problems within organizations. This could lead to data privacy and security issues within organization. Because let's try to understand, when you have an AI system, which is a black box for most of us. When we log into a chat GPT, what we do is we submit a prompt and we get a response out of it, right? So we as end users are not at all aware of what is happening inside the algorithm. And that is what that algorithm is, a black box for most of us. So in a normal world, just try imagining that you're going in an airport and somebody gives you a baggage that can you just take this bag for me and give it back to me once we have deboarded the flight. You will obviously not do, because that's a black box wherein it could be a security risk for you as well. The same thing lies for AI use cases as well. Somebody has given a AI algorithm to you and you have started using it. But the person who has given the tool to you has to make sure that the tool has been built responsibly. And that is where you see responsible AI is an approach for developing an AI tool, accessing the AI tool until deployment so that it can be used ethically. So when I say ethically, just try to I'm trying to put a scenario wherein say that AI use cases are now being used for predicting credit limit of customers or providing loans to customers. So say, or sometimes they are started using it for some criminal cases as well in few of the countries and all. So imagine that if at all this AI makes a makes a wrong prediction or it makes a wrong choice, your end user or the person will be very badly impacted. Say a person might be at a risk of losing his job, even though he is very well capable of it. So say an AI comes and it just starts taking interview, or it is used to uh, filter out the resumes. There could be a point wherein it might miss a very capable guy's resume and somebody's resume might be picked up who might not be very suitable for the job. Same applies for a loan statements as well. Somebody might be given a loan and somebody might not be given a loan just because of his demographics. So when I say demographics, it could be a very racial term wherein you say that you have seen in US or in many places what happens is a particular demography. When I say a demography, consider it as a state in India. People of a certain state might be a minority thing wherein what could happen is that these these minorities are not very well represented in my data and my model has not picked up those patterns. And my model is as good as the data, because only if we train a model, what we do usually, we train a model on data and we get the desired output. So see, you are trying to understand the umbrella, like how my data could be a possible reason for a particular bias in my algorithm and things like that. So when an industry or when an organization puts AI use cases into production, it might have long-term, say, complexities in terms of, say, a legal battle needs to be fought or a security issue needs to be fought. These, uh, if at all these problems comes once the AI system is in use. So the best case is start adopting principles early on, and which we say the left hand side itself, starting from your data ingestion, because once we start applying these principles, only then your model will be very fair, it will be interpretable, and it will be less prone to errors. And that is what responsible AI is about. It is a basket of principles which we need to apply in our AI use cases development, starting from data aggregation to creating machine learning models to deploying them in production. So we have to do it everything responsibly, because say that once you have a loan that has not been granted to you, you always have that rights wherein you go to the bank manager and say that what was the reason for me not getting a loan. But imagine a AI use case has been put up by a bank wherein robots are doing these kind of yes, no, or classifying the person as he's not eligible for a loan. Then in that case, if a person is not eligible, he can very well go to the banker and say, on what basis have you rejected the loan? And if at all the person is not aware of what has happened inside the AI use case, if the organization can be sued for that, right? That you have not acted on my request responsibly. So this is why responsible AI is required as and when we are moving a lot of AI use cases in production. Okay, so when this is how now, as I have said before as well, responsible AI is a set of principles that needs to be followed across the machine learning or AI use case, starting from data ingestion until putting the model into production. So what are the principles, basic principles of responsible AI? These are the 6 pillars which Microsoft has defined, and they are using in all their cognitive services and their Azure machine learning and all the machine learning use cases. So these are the basic 6 principles on which responsible AI is headed towards. So the very first principle is the principle of fairness. So what do we mean when we say a principle of fairness? That my model should not be differentiating between, uh, say that you, girls as well are applying for a loan and boys as well are applying for loan. But probably my data, if I have collected data from say 1970s on, from 1970s to 2023 on the historical trends of loan, probably my data will have underrepresentation for females, because probably just after 2000s and all, we have a larger workforce of females who have started working, and they have started taking loans, and they are well ahead of males as well in lot of things. So if my model is trained on a historical data, you understand under you have an underestimation of one of the sex, and you have a larger estimation of one of the sex. So it could be the case that the representation of females might not be that stronger than male, and it is nothing that what has the model done? It's not a mistake of the model. The model has just learned from our data, and if our data has been collected like that and it has been provided like that to the model, and then if there is a problem in fairness, the model has does not to be blamed for that, right? So that is where before feeding the data to the model, we have to make sure that we have correct representation of each and every features within my model. So that is an example of a fairness for a model. Then we have reliability and safety. So reliability and safety could come to use in industry 4.0 use cases, wherein you have a lot of IoT use cases, your machines are dependent, you have a lot of custom vision problems wherein you are from a distant, from a very long distance, somebody is doing a surgery using robotic arms. Imagine that if at all there is a slight mistake in the reliability and a robotic arm is doing a surgery on a patient, what havoc it could create, right? So such kind of niche use cases, we have to definitely allow the principles of responsible AI. Privacy and security. Data is the new oil, everybody says that. And with GDPR compliance, lot of PII data in use, we have to make sure that your data is not exposed to outside world, irrespective of what, at what place or at what stage of the AI use case you are using your data. You have to make sure that it is secured and private. When we say inclusiveness, it is a kind of similarity to fairness, wherein you need to make sure that each and every data within your each and every feature within your modeling perspective is inclusive. Like when we were talking about the misinterpretation, say misrepresentation of a few sect of people within your data set, say the female representation versus the male representation. So we have to make sure that before we train our model, those, and there are a lot of techniques which the data scientists are well aware of. So we will not get into those details. That is what inclusiveness is. And then at the end we have transparency and accountability. So accountability is something when, say that a person has been denied a loan by a particular bank, he goes to the bank and says that on what reasons my loan has been denied. A person sitting next to me or my friend having similar age structure, same salary, works in the same office, he has been granted a loan. On what basis my loan has been denied? In such cases, if at all this has been a machine dependent choice, then the person using that should be able to explain that on what basis a person's loan was rejected and a person's loan was not rejected. That is where you get transparency and the accountability comes, that okay, irrespective of whatever output comes, if at all somebody is coming back to me asking for an answer, I need to be able to provide him an answer. That is where accountability comes into picture. So these are the principles of responsible AI which we have to make sure to start incorporating as and when we are maturing in our AI journey. And as I have told, let's see, this is a little advanced topic wherein people have not started using it, because first the fight is to get the use cases in production. The very first fight within the AI and the data analytics space is to operationalize the machine learning codes. More than 56% of the codes are not moving from the PPT or the Jupyter notebook environment to the real world. So first challenge is solving that problem. But yes, later on, and big companies have already started adopting it, which we have not seen as of now within our use cases. But the agenda was to make you guys aware of the tool so that you could plan your future AI journey using these tools. So what is the need for a responsible AI? So it's the practice of upholding AI principles starting from our data collection unto model development. This is the need. Why? We already talked about, we do not want to get into legal mess or some kind of a mess of after deployment of my models in the production environment, right? And so how did this idea come into Microsoft's mind? So basically, Microsoft tries to make life easier for all of us, right? So there are Microsoft has provided us a complete toolkit of responsible AI, which is ingrained within their DNA as well. They are using it in all their cognitive services, in all their machine learning services, which are basically for fairness, explaining the model, and trying to see where my models are erroring. So that is where the idea of responsible AI dashboard comes into picture. So a responsible AI dashboard is nothing but it's a single pane which brings all the principles of responsible AI, which we have talked just few minutes ago, within a single window pane for everybody's usage. And like most of the Azure services, these services are also available to you guys in their three ways. One is via the CLI approach, one is via the SDK approach, and one is via a simple UI approach. So if at all you guys are, I think there was a session on Azure machine learning as well for beginners. So if you have gone through that session, you are creating either a classification or a regression model. So once you have the model in place, you need to debug and see how exactly my model is fitting into this responsible AI space. I have created a model of predicting, say, a loan default, or I have created a model for classifying whether it's an orange or an apple. You have a scanner, you go to a store and try to see that, okay, this is an apple, this is an orange. I have created it, but how effectively my model is able to predict or differentiate between an apple and an orange, that is where this responsible AI dashboard will help you guys. So this was just the theoretical aspects of things. So I would quickly show you how this happens in the Azure portal. Yeah. So everybody is aware, I assume everybody is aware of how to create an Azure machine learning workspace within your Azure portal. So say that once you have a Azure machine learning, yes. So you see that you create a machine. You until here, most of you guys are aware of how to create Azure machine learning workspace. If not, this is an easy topic. Anybody, you can go ahead, right click, create Azure machine learning. once you have Azure Machine Learning Workspace, you click on Launch a Studio. So once you launch a studio over here, yes. So you see, once you launched a Azure Machine Learning Workspace, you have the complete set until starting from data ingestion is like creating data, creating pipelines for training your models and deploying your models. So all these things we should be aware of. This was a later expectation. So basically you will have the model endpoints. So basically your models, or when I say that an AI system is exposed to the outside world, so how is an AI system usually exposed to the outside world? It is via REST APIs or your endpoints through which your web applications can access the AI use cases, right? So this is your normal Azure Machine Learning Workspace. You click on all workspaces. Once you click on workspaces, you will have these components over here. Okay. So these are the components. So you will have a lot of components within Azure Machine Learning. And I'm sure that most of you would not have gone until the deep level of machine learning, because as I said that as an industry, we are still into a stage wherein we are still in the process of operationalizing machine learning. Very few organizations have been able to do that, at least in India. So we have, so you see, these are the response. When I say RAI, these are the components related to responsible AI. So what are, you can have a dashboard, you can have a scorecard, causal reference. This would make more sense to the data scientists over here. For people who are pretty new, you will come there, no problem. It will take some time for you guys to learn and come up to that space. But yes, so once you click on those tools, you would be getting something of that, this sort. So before I deep dive into the model, what basically this model is. So basically uh, this model is predicting the price of houses based on the square feet of the house, the basement area, how many say garages it has, and things like that. So these are normal features. So if you would have visited magicbricks.com or housing.com, wherein you want to see what is the rental going in a particular space, or what is the sale price of your house if you want to sell, what are the few features or basic things which you provide in that website. You give how old is your house, what is the pin code, what is do you have amenities in it, how many parking spaces you have, do you have a fire alarm, do you have a security guard, do you have a lift. These are few of the features based on which the cost of your house will be decided, right? So say that this particular problem caters to that kind of a use case wherein we are deciding that we are deciding to predict the cost of a house. So now everybody will be aware that you provide an input to your housing.com or magicbricks.com, and you get the output that okay, this particular area 3 BHK with a car parking and a security guard would be sold for say uh, INR 50 lakhs, something of that stuff. You get an answer of that. But when you are putting in the real world, you need to make sure that that 50 lakhs is justifiable, not that it can come out of the world, because I have been expecting that no, this house should be worth 60 lakhs. That is what as a human you interpret. But your model is interpreting it as say 50 lakhs, or it is interpreting as 80 lakhs. So you need to have a reason for that, right? And that is where using these tools you can debug and you can find. And if somebody comes back to you asking for an answer that why two houses adjacent to each other, probably more or less same area, but for one house it's being predicted as 48, for the other house it is being predicted as 45. So you can obviously have an answer. Why is question? Why is it that? Why is it a reason? So this is where these kind of dashboards will help you to debug that. So you see, what does this mean? So there were a total of 700. See this. There were a total of 730 data points on which my model has tried to predict.
But what were the correct predictions made? 643. And what were the incorrect predictions made? 87. So you know that achieving human parity in AI use cases is not a possibility yet. We have few tools which are beating human, but at least normal use cases which people are using in the industry, we are pretty happy with say 65 to 90% accuracy. We are good enough, because these are not cases where you have a death threat or we are not doing a surgery and things like that. So for most of the industrial use cases, we are okay with the prediction of close to 65 to 90%. So that is what this model has also done. Out of 730 predictions, it has predicted 643 as correct, but it has predicted 87 as incorrect. So see, model is also not 100% accurate. So once you go to the Azure Machine Learning Responsible AI dashboard using the RAI tool there, for your models, you will have such kind of a tree. So when you have a tree, what it is representing, let's take an example of the let's take the previous example wherein I was talking about female representation versus male representation. So this particular node could be your overall accuracy of your model. This could be say a female representation. This could be a male representation. Just that analogy we are trying to do. So we need to see that, okay, now, do you see one good thing about this dashboard? You have lot of nodes which are represented as red. So when we have red representation of the nodes, it implies that there is some problem in this particular nodes. Rest all of the nodes are okay. Okay, and that is where we need to, and this is a software engineering practice wherein we need data scientists and all should not be using this. This is where you machine learning or you software engineers, once you are pushing your code to production, you need to make sure of these things so that you do not have a say a legal you do not have a legal issue once the such kind of use cases come into production. So once you have that, you see you have, let's try to see this model over here. Okay, okay. You see what is the error coverage. So once you see, once you clicked over here, you will see that my error coverage is 100%. And what is my error rate? So my error rate is nothing. What is the percentage of wrong errors, percentage of wrong predictions which my model has done on the overall total predictions made? So if you see that, uh, 87 out of 730 could be close to 11.2%, 11.92. So it is making sure that my error rate, my model will predict, have an accuracy of close to 88%. In 88% use cases, it will be correct, but there are 11% use cases where it will be wrong. So we have to be more careful about those wrong use cases, because correct use cases, nobody bothers. But those wrong use cases wherein you have a, sometimes you might have a human life involved, is very critical. Somebody is waiting desperately for a loan, or somebody gets a jail term because of this, or somebody does not get an admission just because of this, would be very critical. And we have to focus on these critical things, because it should not be that somebody comes to my college at a later point and says that why have I not got an admission in spite of me being a meritorious student. That's why we have to, and this tool called the error analysis tool helps us do that. You see this, it's highlighting and it's showing that this is a red, this is something red which we need to understand. And when you click on this, see what happens. This is a traversal for my model wherein it says that my living area for all my houses wherein the living area is greater than 1078 square feet and the build is less than 1978. So it is an older house. You see, these are very old house, old, and I would not say very big house, but yeah, these are houses which are older than 1978 and they have an area of 1078 square feet. The model is giving me more wrong in such kind of cases. So can you guys just guess what could be the possible reason for this? I think we discussed about it, like what could be the possible reason. So, okay, before that question, let me say one more thing. You say that my model is my model is accurate up to 88%. On what pockets it is accurate? It is accurate on my whole data set of 730. 730 data set. It is 11%, it is 88% accurate. But there would be few pockets, like we talked about the male versus the female representation in the data, wherein it might be biased towards few things. And that is one of the reasons, that could be one of the reasons for this, wherein we might not have a good representation of houses older than 1978 and having living area greater than 1078 or something of that sort. So such kind of representation is very less in my model, and that is why my model would not have picked up such representations, and it is erroring on that. So basically, normal machine learning model, we concentrate on the whole data set, wherein I am very happy 88% accuracy. But within that 88% accuracy as well, there would be few pockets wherein my model will be good at predicting, but it might be bad at predicting few pockets. And that is where these things come into picture. So you see that what happens in normal use cases, whenever for houses where my living area is greater than 1078 and my year of build is less than 1978, it is giving more errors. So you see what is the error percentage over here? It is 25%. So imagine how my error rate has reduced drastically. So this is basically, so yeah, so you see that basically this is how you get into each and so when you see this, how do you compare it to your normal software engineering practices? Don't you see these are like unit tests within your software engineering Java or a C# code? But until now, nobody was doing such kind of unit testings in your AI model. Have you guys ever, if at all you guys are working on AI use cases, have you ever come across you ever come across scenarios wherein you are using unit test cases for individual pieces? I don't think so. Everybody is busy in collecting the data, getting a dedicated accuracy for a model on aggregate data. Nobody wants to, or we have not reached that space wherein we want to say work on specific pockets of data. And this is one of the tools from Microsoft which will help you to get into the inside. So once you have this picture in mind, before moving into production, what would you say to your data laborers or to your business users that guys, I do see that my model will start failing if a lot of people who are having old houses greater than 1000 square feet start selling their house. We will be misrepresenting them, and 25% of the cases will be wrong cases. Do you still want to put that into production? Then the business team would be like, okay, let's see how we can solve it. There is no other way to solve it rather than having more representation of such kind of data into. There are other data science needs as well. There are other data science concepts as well which you can use it. But when will you use it? Only if your data science team understands that. You go to them and tell them that guys, see, your model overall accuracy is 88%. But when it comes to old houses, big houses, the model accuracy is reducing to 75%. This was never the case before the use of such kind of tools, because nobody was able to get such fine grained access on such kind of data. This is where, and when Microsoft has given you such kind of tools, this is where you would be able to develop things responsibly, right? So if this tool was not in place, what would you have done, or what we would have done? We would have simply thrown this AI use case in production, and most of the time it would be happy. But people who are selling their old houses, they would have come and thought that was, I see a crap in your AI model. What is it? It's not giving me it's saying that my house is just worth, say, 60 lakhs. Probably it should be more. What answer you will have? That person might have the right to sue your application as well. That no, not at all. This application is not giving me correct result. So what using this tool, what we have done as software engineers or as ML engineers, we have caught these errors early stages, and we have tried reiterating the model, wherein we will go back to data scientists, tell them this is an individual error, try to work on it. They will come up with their construct.
And slowly, this is where at the end all your models will have say zero accuracy or very less accurate, zero failures or very less. We would always want to achieve the left this side of the spectrum, right? Rather than having these red. Who wants to have failures? Nobody wants to have failures, right? We want to get the correct result from our AI model, and this is what this error analysis tool within Azure ML framework will help you to get fine-grained details of the models which you are trying to put into production.
So, okay, with this, I'll end my session. I understand probably it might be a little, it's basically, see, Microsoft, this is a tool from Microsoft Research, okay? It's not, it has not been incorporated very well in the industry now, but yes, people have started using it. And if we want to use it, you just need to go to responsible AI resources. And this is where there are other tools as well. I talked about fairness, I talked about interpret ML. This is where you will get, so just go to responsible AI resources and you will get a whole plethora of toolkits to start using in your use cases. And as I said, first let's concentrate on moving our use cases to production. I have already been through that stage, so that's the reason I'm just trying to incorporate such things into my use cases now. So the first thing is moving into the MLOps space and then to the responsible AI. But yeah, this is an interesting space which is evolving, and probably 5 years down the line, when we have a lot of use cases, other industries will also will start using such AI principles, because this is a must for any of the use cases which we want to operationalize. So yeah, with this I end my session.